in a way that I had actually never seen before. At the end of the video, we have a short debrief session where we talk about how the interview went, and on top of that, I just filmed a very small commentary that I added in the middle of the interview just to kind of share my thoughts about how he did during the first half of the interview. With that, enjoy the video. Okay, so Camille, I just started the 45-minute timer, and we're gonna dive right into the coding interview question. So I want you to imagine an XY coordinate plane, right? You've got the x-axis, you've got the y-axis, and you've got coordinates on the plane. Does that make sense so far?
I did.
Okay. And
I can handle 2 dimensions.
You can handle 2 dimensions. So
yeah, with like 11, it becomes hard, I guess.
Right, up until 10 it's okay, but at 11 it becomes difficult.
Exactly.
So I'm going to give you a list of XY coordinates, so Cartesian coordinates on the plane, and I want you to write a function that is going to tell me how many rectangles are formed on the plane by these coordinates. So for instance, if I give you this, you see how I copy pasted like 6 dots, yeah. Right? You can imagine that the XY axes are maybe like here at the left side. That's the y-axis, and then the x-axis. It doesn't really matter. And you can imagine that here there are 3 rectangles that are formed, right? There's one that's sort of like this first square.
So there are 2 squares, the left one, right one, and there is the big rectangle.
The big rectangle, exactly. So I want you to write a function that takes in these points and that tells me how many rectangles there are. There are 2 little caveats. First of all, a rectangle has to have 4 corners on the plane to be considered a rectangle. So for instance, if I delete this one, then you lose quite a few. I think you lose 2 of the rectangles. And
I agree. Yep.
And then for now, we're just going to deal with rectangles. That are parallel to the x and y axis.
Yeah.
So they're
this was going to be my question. What would happen if I added a row here, and now would these 4 points, would they create a rectangle that I should count?
So for now,
I guess for now we don't.
For now we don't. For now we don't.
Okay. Well, I don't know if you're aware of that, but I'm quite good in computational geometry, so it's up to you if you want to leave this problem as it is.
Let's leave the problem as it is, and we'll see if we can improve it soon.
That's fine.
I hope to come here soon.
Okay, so we want to count rectangles made of 4 of points from here. They should be parallel to axis. I guess the professional word for that is like isotic. There is a word for that, I don't remember.
Yeah, there is one word.
It's something with I. Anyway, I would say that we're looking for such quadruples, like say x, y, then the other point has the same coordinate x, but different y, then some different x, y, x2, y2.
Yes.
And now I will also make my screen bigger. And we are looking for 4 of points like that. where x and x2 are different, because otherwise we would count the degenerated rectangles with like 0 area.
Yep.
And y is not y2. And this is our goal. What makes sense is to iterate for sure over one point. So I'm not yet sure what I'm going to do fully, but some pseudocode would be that I iterate over 1 point in points. And this will be my x and y.
Right.
If I was able, for example, to iterate over the second point with the same x, in brute force way, it would be p, let's say, above in points as well. If px is equal p above dot x, and not to overcount something, let's make this p above to be indeed above, so y coordinate will be bigger. If that, then we continue. And what I found is a pair of points that is, one is above each other, like this pair.
Right.
And I need to find matching pair that is on the same level. If here I would just increase some counter by 1, I would count like vertical lines that can be created.
Sure.
And instead, here I will say that what matters are variables py and p above y. Also, I hope that writing in C++ like code is fine.
That's totally fine, yeah.
We have py and p above y. I want to count the number of other pairs that produce the same pair. My idea is to here increase the count for a pair py p above y, where this is, say, a map or a hash map. For now, in C++, I would start with a map from pair to int.
Right.
I called it count. Count. This is count pair y pairs like this, like with this y and this y coordinate.
Right.
Kind of count vertical lines. This would give me logarithm in complexity. What I could also do is put a hash map here and an ordered map, and then to make it work in C++, I would need to define some hash value of a map. I think it isn't there by default, at least in C++. But for now, it isn't important for the logic. Count that, and maybe just before, I would say answer plus equal count of same. So not to repeat something, I will, assuming that coordinates are ints, this pair of y, I will call make pair py p above y. Let's not make it ugly. And here, increase the answer by count of that, and increase the count of this pair.
So basically,
this way, first.
So sorry to cut you off. Just to make sure that I'm following correctly. Basically, you are iterating through all the points here. Then for all the other points, you're looking for points that are directly above it. This is your if statement,
exactly.
Right? And here you're saying, okay, I've got one vertical line, and which is this pair, and then you're going to say, we're going to count all the other vertical lines that are exactly on the same level.
Yeah,
okay.
And thanks to the fact that I do it in this order, at this moment, for line with answer plus equal, I add to the answer the number of pairs, the vertical lines that were already processed, and then only I increase the count by 1. So if it happens that first some pair appears, then for a moment this count is 0, so it is answer plus equal to 0. Only then I increase the count by 1. And if later, on the left or right, doesn't matter for now, let's say, this will be used. The count will be, count is already 1, and then I get answer plus equal 1 when I get to this second vertical line.
Gotcha.
What I'm not sure about is whether maybe I double count, like when I'm on left line, I count the right one and the other way. But then I think this order prevents from that.
Why does the order
Whenever
prevent?
I meet the first pair, only then I increase the count by 1, and later, no matter if the other pair is on the left or right, I will increase the answer by 1, right?
I see. Are you when you are I guess we should explore what this make pair function looks like, right?
Yeah, it's just a tuple. I guess this is.
Or no, sorry. Then we should.
Even,
I see. I see. I see.
This is also correct. Just I could paste that here and there, and that's it. So it's just not to repeat code.
Right. Okay. So keep going from here then.
Yeah, and I think this way, those two for loops together, they iterate over all the pairs of points. This way I check if I have a vertical line. So here, if I wanted to print those that pair here, this thing would print all the vertical lines, but I don't want to print. I want to count pairs of those vertical lines that are on the same level.
I see.
Each vertical line is defined by pair y, and I want to count pairs that are same. Some alternative for that would be just to do this, like not to increase answer here. And later, if I know that there are, say, 10 pairs on the same level, I could use some simple math formula to say what is the number of rectangles from that. I think it would be 10 choose 2, which is like 10 times 9 divided by 2.
Right.
But I find this one to be more elegant, and here return answer.
All right, you do have the answer from here. Okay, now I understand what you're doing. At first, for some reason, I thought